Hello there. This is the vector application with the jet flying in the wind. This is kind of a classic example of using vectors. So we're given the speed and or distance, maybe the direction. In this case, we're given this type of bearing. And then the wind is blowing. We're given its speed and its direction. So bearing, heading mean the same thing. It might say direction of, same thing. You have to know that this format is the angle from the vertical indicated, north-south, and in order to correctly use the calculator, you have to make an adjustment. I prefer adjusting the angle. As you can see here, the 44 is there from the north, and then the theta that we're going to use, we just subtract that from 90. And I talk about this in the bearing video and notes that I did. Each quadrant, you do something a little different depending on the quadrant. How do you turn it into what angle to use? So in this case, we're going to take that 46, plug it in. X is the magnitude 765, cosine 46 degrees. Check your mode. If you're in radians, you'll get wrong answers. Y is 765 times sine 46 degrees. You see my numbers there. I always keep a few extra decimal places. The instructions might say round to 2, but we're going to use these numbers in several steps. So if you round too much, you might introduce an error by the time you get done. So just keep a couple of extra decimal places as you go down. Same thing for the wind. Both of these were in quadrant 1 northeast. So I'm subtracting from 90, adjust, appropriately in the other quadrants. Part C, the true speed, requires the resultant. So I've added the vectors together, add the x's, add the y's. We need the magnitude. Remember that double vertical bar is magnitude for vectors. Sometimes you see a single vertical bar. You have to know in context that it means magnitude and not absolute value. Otherwise known as Pythagorean theorem, right there. Part D is the actual true direction that the jet is going. The wind is blowing against the jet, so it's changing that angle there. And I recommend whatever your resultant values are, when you do alpha, the reference angle, with your calculator, just make those numbers positive. That way your angle's positive, and then you can adjust it accordingly. If you type it in with the negatives, you get a negative angle, and that might confuse you about what you do. So anyways, that's my recommendation. Make it positive there. So in order to answer it as the correct bearing, the alpha is the angle from the horizontal, and we want to go to the bearing angle, so we'll subtract that from 90. So if you do the thing I said with alpha and make the numbers positive, no matter the quadrant, you always subtract from 90. The letters that you use specify the quadrant. So quadrant 1, northeast, put that 43.003 degrees in between those two. That is the end of this example. I've got another one for vectors, but that's all I got for this one.